Congratulations! You have finished our mini deep learning workshop. And now the next question is, what do you do now? If you're expecting yourself to be an expert, nope, we're not there yet. This really should be the start of your learning journey. This field is so new and so many fresh discoveries are being made every week that I don't think in 2017 or even in 2018 you could create a comprehensive deep learning textbook. I don't think that's possible. So what we're hoping you have now is a set of tools, a workflow that works, and an intuition for how baseline deep learning models work. Everything else is now up to you. As part of your learning journey, I strongly recommend that you read research papers on Arxiv. It's an open access library of computer science, statistics, physics, and mathematics papers. ML researchers, it's a point of pride for them to put up their preprints on Arxiv. So in many ways, it's even more advanced than the proper publications themselves. Arxiv Sanity is a really nice interface on top of Arxiv to make it more readable and sortable, because Arxiv is just a pretty raw dump. And we have linked to it in the text associated with this video. Online classes, there's so many, and there's so many really good ones. One of the reasons why we've kept this mini workshop like very short and very surface level is because every topic that we've touched on a surface level actually expands out in like almost an infinite fractal manner of online materials for you to go through. You just have to get through them, and now ideally you have a community of learners to work with, and you know the basics well enough that you're not going to be thrown off by any of these things. There's a couple of classes we highly recommend. They're much more dense and they're very thorough. They can be a bit too mathematical for some people, but I still think they're quite good. They're all Stanford courses, fully online, most of them on YouTube, quite a few of them. Their whole syllabus and all the exercises are online as well. If you are interested in doing further research with TensorFlow, if you want to write your own papers, build your own activation functions, this course, 20 SI, TensorFlow for Deep Learning Research, is great. If you are working with language processing and you want to learn next about RNNs, LSTMs, sequence-based deep learning, this is the class to take next. 224N, Natural Language Processing with Deep Learning. If you have gotten a taste for convolutional neural networks and visual for images and visual recognition, 231N, super amazing. You'll find that quite a lot of the material we've already gone through in more of a surface way in this mini course. Next, you should follow the top machine learning conferences. So a lot of the forefathers of deep learning are still around and still, frankly, extremely productive. Everybody shows off at these big annual ML conferences. If you get an opportunity to go, it's nerd heaven. Do it. Two conferences that are the most where all the coolest papers tend to show up at. One is called NIPS, and one is called ICML. And the 2018 NIPS is going to be in Montreal, and I think ICML is going to be in somewhere in the United States. But again, excellent opportunities to really meet the people in this field. You should also think about following the top corporate research labs. So in this day and age, a lot of the best researchers have been poached by companies, but they've brought in the academic ethos with them. So then you can read the Google research blog to see what they're up to. All of these corporate labs also publish at these machine learning conferences. Oops. There you go. The Google research blog is fantastic. The Facebook AI research blog, pretty good. Databricks is they are a company that provides machine learning in the cloud services, but they have a very good blog. Stitch Fix sells clothes, but they have a really amazing engineering blog. YHat is another one of those companies that is a bit more niche, but has a great blog with learning resources. So just to show you an example of the really cool stuff that comes out of these places, we've talked a bit about how to classify how to classify, how to predict with deep learning, we haven't really looked at interpretability. And interpretability is still one of the major challenges of these algorithms. They're still very black boxy. There's a current school of thought about making interpretable AI, and that's going to be very important for us as artificial intelligence techniques are adopted into more and more technologies. Imagine the policy implication of giving somebody a credit score based purely on data that no one can interpret or explain. In Europe particularly, governments are starting to push back and demand that AI algorithms be able to show their work so that us humans who operate via reason can evaluate decisions being made for us by these algorithms. So this is a very interesting piece of work done recently. It's on TensorFlow called Saliency. What it is doing is it's taking this picture. So a normal CNN would label it tricycle. But why? So this uses integrated gradients and guided backpropagation to show you what region in the picture most influenced the classifier's decision to call this a picture of a tricycle. So this is a couple of different methodologies. This one gets to the point where it's really good. So this is how a human would have interpreted the image as well, by looking at this picture and recognizing that it is the focus of the image. Last note, talking about interpretable AI, we have to think about ethical machine learning. So neural networks are really only as good as the training data you feed into them. Quite often, this data comes from the internet because that's an easy source of data. If you do that, you can accidentally teach your model some very, very, very bad things. If you pull data off of Reddit and train a word embedding neural network on Reddit data, you might end up with something that considers Mexicans linked to illegalness and only ever tags nurses as women, or visual classifiers that don't know how to recognize people who don't have white skin, or Asians. There are a lot of Asians working in these AI labs. So that's just something to keep in mind. When we build these models, your data sources, because they're not so interpretable, your data sources become very, very important. And we do have an ethical responsibility to do this work, to do it well, and to think about how our work impacts everybody around us. So thank you for being part of our little workshop here. Thanks again to the Department of Science and Technology for working with us to put it together. And good luck!